Hello and welcome to this episode of Math with Martinez. In this video, we are looking at both formulating and solving equations that involve variation. So let's go ahead and get started. Now, just what exactly are variation models? Well, what it is it's a special type of relationship between our variables. And there are three types of variation models that we will be seeing. The first is direct variation. Now, a direct variation model is going to follow this kind of format. Y equals K times X. And we read that as Y is directly proportional to X. And that K value right here that's multiplying with X is called the constant of variation. It's going to be some number value. Now, joint variation is going to look like Y equals K times X times some other variable Z. And we read this as Y varies jointly as X and Z. So there's more than just the two typical variables of X and Y. We have yet another one in this joint variation. So the output of Y is going to depend on two different things. And then last but not least of all, and the one that we're focusing on predominantly this unit, is inverse variation. And that follows the form Y equals your constant of variation divided by your X. And this is read as Y is inversely proportional to X. And you can see here why this is the one that is our emphasis in this unit, because this is actually a reciprocal function, right? You've got 1 over your variable, creating a little rational expression. So let's go ahead and look at some direct variation examples to begin with, both formulating and solving. If Y is directly proportional to X and Y is 28 when X is 7, find X when Y is 52. I read that so fast, but now let's go ahead and translate that, write an equation, and solve this problem. It says that Y is directly proportional to X. And so that means it's got to follow this kind of format when we're writing our equation. So that looks like saying Y is directly proportional to X. It's going to have this format. It goes on to say when Y is 28, when your X value is 7. And what we want to find out on the other side of this is we're going to find out what is our X value when Y is 52. So we're going to use our equation. We're going to substitute in to that equation, and then third and lastly, we will answer the question really posed to us, which is finding X when Y is 52. So I've written my equation. Now let's go ahead and solve for our K value. To do that, I would need to go ahead and divide by 7 on each side. And dividing by 7 on each side is going to give me what is my value for K? K is going to be let me scoot this up just a little bit. What do we get when we divide 28 by 7? That is going to be 4. Which means our equation is actually Y equals our K value, our constant of variation is going to be 4 times X. So that means if we let our Y value be 52, then we can go ahead and solve for X. We'll do that by dividing each side by 4. When we take 52 and divide it by 4, we get 13. There you have it. Now why don't we try another one similar. It says R is directly proportional to the square of S, and R is 72 when S is 12. Find R when S is equal to 8. All right, so let's go ahead and work through this. It says that R is directly proportional, so that's going to say K, our constant of variation, just following that formula. But it says to the square of S, so I need to take S and square it. It goes on to say that R is 72 when our S value is 12. And what we're going to do is once we know our equation, then we'll go ahead and, like we did here in step number 4, we'll plug in and solve to find our value of R. But let's go ahead and finish this off. I have 72 equals, what exactly is this going to be? It's going to be 144. I'm going to need to divide on each side. And my numerator is smaller than my denominator, so this is just going to be a fraction that I'm going to simplify. And when I take and simplify that, 72 divided by 144, that gives me my K value is 1/2. So now when I write my equation out, I have R is equal to my K value times my S value squared. And we want to find R when our S value is 8. Well, that's pretty nice because all we're going to need to do is go ahead and take our calculator and use it to simplify this expression. Just so you can see that. That means I'm going to take, let me split this view actually. There we go. I'm going to take my 1/2 and my 8 and square that. And that gives me 32. Cool. Let's look at this next one. It says that the dollar amount D that Megan earns varies directly with the number of hours H that she works. Okay, let's take a moment to write out an equation representing this. The dollar amount D varies directly, so multiplying with that constant of variation, with the number of hours that she works. So if D goes up, H goes up. If D goes down, H is going down too. In her last paycheck, she earned, so the dollar amount that she earned is $148.50, and this was from working 18 hours. If her next paycheck is $975, how many hours, $90.75, that would be how many hours did she work? Let's go ahead and see if we can solve this. What we need to know is our constant of proportionality. In order to find that, I'll need to take my 148.5 and divide it by my 18 to isolate that K. And on my calculator, I did just do that, and that gives me my constant of proportionality is 825. Okay, so when I plug that in for K, if I plug that in and then plug in what the paycheck amount was, I'll be able to figure out just how many hours she worked. Again, how will I do that? By taking 90.25 and dividing it by 8.25. I'm sorry, 90.75. And that means that she worked 11 hours. So to answer in the context of the problem, that's 11 hours. That is direct variation. Okay, now let's take a moment and look at some joint variation examples. In much the same way, we will use our model here. Oops. We'll use this format for our joint variation. We'll solve for our constant of variation, and that'll help us to answer problems where one of our variables is unknown. So it says if y varies jointly with x and z, y varies jointly with x and z. Okay, so that means when I write this out as an equation, it would be y equals my constant of proportionality multiplying with x and z. It goes on to say if y is 48 when our x is 8 and z is 15, we're going to want to find y when x is 14 and z is 20. So my final, I'm going to want to come over here and I'm going to want to say what's y. I'm going to need to know my k value. My x value is going to be 14 and my z is going to be 20. But before I can find y, I'm going to need to know that k value. So let's solve for that here. When I take 8 and 15 and multiply those together, that is 120. And we're going to have to divide each side by 120 to get k by itself. So when you take 48 and divide it by 120, that simplifies to the fraction 2/5. So our k value is 2/5. Then with your handy-dandy calculator, you'll be able to evaluate this and see what is the product of 2/5, 14, and 20. That is 112. There we go. Let's do another. It says that P varies jointly as Q and the cube of R. So we're going to take R and cube it and make sure all this multiplies with our constant of variation. Then it goes on to say, and P is 270 when your Q is 6 and R is 3. So K is still unknown to us. We're going to go ahead and solve for K, and that's going to help us to answer the rest of this question. When you take 6 times 3 cubed, the result there is that K is actually multiplying with, that constant of variation is multiplying with 162. Dividing 270 by that amount, when we express that as a fraction, is going to be 5/3. So now let's go ahead and answer and find what is P. We know our K is 5/3. If Q is 3 and our R is 5, 5 is, again, having to be cubed. If we go ahead and take and find the product there, that's going to be that P is 625. There we go. Now, lastly, let's look at this in context. For Tom's saving account, the interest earned varies jointly with the principal amount of time and years since the opening of the account. If Tom opened the account 3 years ago with $1,200 and earned $144 in interest, how much interest will he have earned 8 years after opening the account? Okay, so it would be an equation set up like so. It says that the account, for Tom's saving account, the interest earned, so we will use I for interest, varies jointly with the principal amount and the time in years since it was opened. So interest is jointly varying with those things. If Tom opened the account 3 years ago, that's time, with the principal amount, which is the initial amount, let me set this up. I don't know K, but the principal amount is 1200. And again, that was 3 years ago. And in doing so, he earned, the amount of interest was 144. Now we can find that constant K and be able to find out the results after 8 years. So if I take and find the product on the right side, this is going to be K multiplying with 3,600. And when we take and divide each side to get K by itself, that gives me that my K value is 1/25. So now let's go ahead and see if we can answer this question. Just how much interest will he have earned if our constant of variation is 1/25 and the principal amount, again, is back to what we started with, the initial amount, but now we're allowing time not just to be 3, but 8. Let's see the result here. What is that going to be? That gives us the total amount of interest, or I, that he earns would be 384. So that is $384 of interest. There you go. That is joint variation. Now, we've seen both direct variation examples and joint variation examples. We are going to go ahead and now look at inverse variation to close it out here. We'll save combined variation for another day. So we're going to do 3 more here. It says y is inversely proportional to x. And so this is where we're going to see that equation that looks like a little rational equation. So we have y is inversely proportional to x. We're told that if y is 7.5, when our x value is 8. So let's go ahead and find our value for k. To do that, we would need to multiply each side by 8. And in doing so, when you take 8 times 7.5, that's going to give us a k value, of 60. So with that, now we can go ahead and say, if y is 5 and our k is 60, let's go ahead and find our x value. Okay, how do we solve this? Our unknown is in the denominator. We've got a rational equation here. This one is really quite nice because technically this is over 1. So we will cross multiply. That gives us 5x equals 60 is only multiplying with 1, so it's just 60. And then last but not least, we will go ahead and divide. And when we take 60 and divide it by 5, that's going to give us 12. Okay, Just a couple more. It says m is inversely proportional. M is inversely proportional to the square root of n. Okay. It says that m is 27 when our n is 16. And we're going to figure out what's the m value when our n is 64. But in order to do that, we need to find our k value first. All right, so let's go ahead and simplify this a little bit. I know that this is actually, if I were to rewrite this, I'll rewrite it down below. Let me make this just a little bit smaller here. There we go. When I take the square root of 16, that's actually 4. So I'm going to need to get k by itself, because I'm dividing by 4, I need to multiply by 4 to undo that division. And when I take 4 times 27, that will give us 108. So right here, I have 108 is actually my value for k. Now plugging that in and dividing it by the square root of 64, which is actually just 8, is going to give us, as a fraction, we can express that as a fraction, that's going to give us 27 over 16 when simplified. Ah, what a beautiful problem to end on. Daydreaming of Disney World. The time it takes Adam to drive to Disney World varies inversely with his average rate of speed. Of course, because if you increase your speed, then you decrease the amount of time. That's an inverse relationship. If Adam takes, well, let me write this out. The time it takes is going to be inversely proportional to his rate of speed. If it takes Adam, I'm going to write this next to it. If it takes Adam 10.8 hours, an average speed of 50 miles per hour, how long would it take him at an average speed of 60 miles an hour? What would be that time? Okay, so in order to figure this out, I've got step number 1, I've got the basic equation written. Now I need to solve there in step number 2 for my k. To do this, I'm going to need to multiply by 50 on each side to eliminate that denominator and isolate for my constant. So when I take 10.8 and multiply it by 50, that's going to give me 540. So my k value is 540. So if I go ahead and just simplify that on the right-hand side, that'll give me the amount of time it takes if Adam's average rate of speed is 60. So if I take that and divide by 60, then that means the time it's going to take him is only 9 hours. Lucky duck. He doesn't live that far from there, does he? All right, y'all, that is a snapshot of 3 different types of variation that we can see. Direct variation, where it's directly proportional. If you increase one variable, the other will increase as well. Inverse, here on the other side, those are going to be like we just saw with our Disney example. If you increase one of the variables, the other will decrease at that proportional rate. Now, joint variation are those that deal with more than just one variable like we saw in a bank account. It depends on more than just one thing. It depends on the initial amount and the amount of time. So the output is determined by 2 different inputs. That's it for today. If you guys had any questions while watching this video, please take a moment to share those now. And until next time, stay fired up.